masters, masters 1, the one that's running the jobs, and we kill it. Control C. Oh, we might have had a problem because, never mind. So we killed it. What happened? So the web UI goes down, and on the slave, it figured out that something got killed, hopefully. And it may have already done this, or at some point it'll say found new master. If it has done it already, we'll see here that the slave and the frameworks both consulted Zookeeper when they noticed that the master went down and said, "Who's the new master?" And they found the second master. Okay, so and hopefully this guy over here is still making progress. Was that backward progress? Yeah, so they're still making progress. You can see. So now another. That's the gist of the demo. That we have fault tolerance in Mesos. We should be able to kill one of these job trackers trivially. The one that's got errors there, and the other one should obviously stay running. That's word count. Okay, so neither of the job trackers had errors. If we kill one of the job trackers, it goes away and the other one automatically gets all its tasks because it's the only person in the cluster. So the whole idea being that now we don't have a single point of failure for jobs, for Hadoop jobs. For instance, inside of Facebook, the spam department who runs their own set of Hadoop jobs doesn't want to be a victim of the ads department when it runs a faulty MapReduce job that kills the job tracker. So, true story. And this we think we've enabled that already. So one final thing before this job finishes, it hasn't yet, whichever one is still running, is let's try killing both masters. So this is completely untested. Okay, so both masters are shut down. So both of the web UIs should be down. And now the slave figures out that both masters are down, and it just sits there waiting and consulting Zookeeper until another master comes up. So now if I bring the first master back up, hopefully, we can actually first just double check that this is still actually making progress because it knows where its task trackers are. The slave is still running, waiting to spawn a Mesos master. And the slave doesn't go away because it's just waiting for a new master to come up. So there's a lot of Mesos, like we said, tries to maintain as little state as possible. It's all soft state. So the masters are both down, and the framework is still making progress because it can consult with the slave. Obviously, if I killed the slave, then there would be no progress. But now if I bring this master back up, then hopefully the frameworks and the slaves find it right away. And then, when its tasks finish, the slave would need to consult with the master again to figure out if it can, reallocate resources because the master really controls everything. So that's I'd say, a successful demo for my purposes, and that's it.
Yeah, okay, so, do you want to, is it okay if I spend like 5 more minutes on this?
You can tell people to stay around if they want.
If you want, people can stay on. What do you have? It's just like 5, it's this other thing. It's another shorter than mine. Sure. Okay, thanks. So actually, we're a little bit over time, but if you want to stick around, we had one other thing we wanted to show you in maybe 5 minutes, which was Spark, this new sort of interactive mapping we've been working on. And we think it's kind of cool, especially if you like Scala and high-level coding. So.
Do you have lights here?
Doesn't. Yeah, oh, great. Yeah. this will take about 5 minutes, but it is kind of cool, and it's one of these things that is enabled by Mesos that we're excited about. So, we said at the beginning, people will want to run non-Hadoop applications on data. And, it's easy to say that, but it's even better if you give an example of one. So we sat down and we decided to pick a workload that Hadoop doesn't handle that well in its current form, which was iterative jobs, and try to do a simple framework that does better at that. That's Spark. And really Spark does two things. One of them is it tries to support these iterative applications. That's one thing. And then the other aspect is kind of fun, is we wanted to make it very easy to program. And so there's two neat features there. One of them is integration into the Scala programming language. This is a higher level Java-like language on the JVM. Maybe you've heard of it. It's a little bit like Clojure and all these things. And the other thing is you can actually use Spark interactively from an interpreter, the same way you use Python and so on. And it's pretty cool with the language integration. You're basically writing MapReduce jobs interactively. And the trick, the thing that makes it better at these things is that Spark gives you over MapReduce is this notion of persistent sort of in-memory data sets that stay around between your jobs. So when you have an iterative application, for example, where you're running many queries on the same data set, you can tell the system, hey, keep this data around in memory because I'm going to use it again right after this finishes. And we call that resilient distributed data sets, or RDDs. But I'm just going to show how they work by example, hopefully. So let's see. This is just checking if my internet is on. I should have gone to Yahoo instead. Okay, so we have a terminal here. Maybe it's still on. It is. Wow. Okay, so here I've set up my own EC2 cluster. This is a little bit bigger. It's actually 16 extra large nodes. And what we're going to do on it is text mining of Wikipedia. So on these nodes, I set up an HDFS and I loaded in this text version of Wikipedia. And we're going to do that interactively, and we're actually going to load Wikipedia in memory and see, how much faster it is to do interactive queries on in-memory data. So Spark has this interpreter. One of the main features is ASCII, but okay, so here it is. So this is a Scala interpreter. I'm not going to go too much into Scala, but it's just a general purpose language like Java, and you can do the type of stuff you do there. And a special thing it has is this SC. It's a variable that's a Spark context that we actually use to submit jobs to Spark. And we're going to work with this Wikipedia file here. So first, let's have a variable that defines that. Oops. And I have a path in HDFS where I put this thing. Okay, so we have this file. This is, it hasn't loaded the file into memory or done anything like that yet, but it has this text file. Let's look at what the data looks like. So you can do that with file.first to see the first element. So this is a tab-separated file with Wikipedia articles. First article is on anarchism, apparently, and it has each element of the file, each line of text is basically an article, and it has 5 fields. It has an article ID, has a title, last modified date. It has this huge XML thing that you don't see here, and at the end there's a plain text field also in this format. So we really, in this demo, we're only going to work with the titles and the plain text. So we're actually going to define a class article that will just pull those out. And this is how you define a class in Scala. It's a class with 2 fields. And now we want to actually get the articles here. So we're going to do that by mapping the file, same thing you do in MapReduce. Sorry, a bit of internet slowness here. Let's see if it comes. Yeah, okay. So we're going to actually do a couple of things. So first, we'll take each article, each string, and split it by tabs. This is how you do it. And then we're going to pick only the ones with 5 fields because it turns out that some special pages like images don't have 5 fields. Okay. And now we have these arrays of tab-separated fields, all of length 5. And we're going to use field 1 and 4. These are the title and text. Okay, so now we get this mapped object. So all these IDD objects are lazy, so nothing has actually happened on the cluster until we try to use it. And I'll show you how we do that. So let's try to do something useful now. Let's try to see, we're going to see how many articles mentioned the AdLab, which is where we are from, UC Berkeley. And you can start taking bets on this. It's not a very high number, but okay. So yeah. So now I did a count there. So now it's actually running stuff on the cluster. And it's doing this stuff. And here, basically I wrote a MapReduce job in Scala that we're running on the cluster. It's running all these tasks. And hopefully it will finish them at some point. Maybe this is internet slowness again. Okay, there we go. Okay, so it took, it said, okay, one article, so it's not a lot, but hey, at least there's one. And it took 16 seconds. Okay, so 16 seconds, it's not bad, but it's not really what I'd call interactive. If you have to wait 16 seconds between every query, that's kind of a long time. So the other thing you can do in Spark, which is different, is you can tell it, hey, this data set, I'm going to be running many queries on it, so cache the pieces of it in memory on all the nodes. So each node will have some of the articles in memory. This is what we did here. We defined this cached IDD. And let's try to use that one now. So the first time you use the cache, the first time you use it, it's going to be just as slow as before, maybe even slower, but we'll see. So it's running and doing its thing. Okay, so it took 20 seconds. Okay, but now the second time you use it, all this data is now in memory, and oh man, this network is being slow again. Chooses a bad time. Okay, so yeah, okay, so that's the difference between working within memory data and working with on-disk data. Once you've loaded the data in memory, this query took 1.5 seconds. And once you have the data in memory, now you can do a bunch of other interesting things on it. So for example, say we wanted to find out which article this is that mentions the AdLab. We could do this. Collect is just give me back. Okay, and there you go. It's the article on David Patterson. And really, all of Wikipedia is in memory. So we can start doing other things here, like counting how many articles mention Berkeley. Okay, and it's about 10,000. And counting how many articles mention Stanford. Oh, it's only 8. Oh, yeah.
Versus, I don't know, somebody else.
No, let's not do that. This is okay. I'm sure you have to win. I just don't want you guys. Okay. So yeah. So anyway, so that's it for us. So thanks for sticking around. And yeah, really, what we wanted to say is, Mesos is this cluster management platform that we think could be useful, and we've open sourced it, and we want it to turn into a good part of the Hadoop ecosystem eventually. Spark is this new framework you can play with on top of Mesos. All of these are open source. They're very early alpha, but if you're interested in them, you can actually try them out. So thanks.
Thanks for staying around.